Okay, guys, we're going to get started. Hopefully you're here for programmatic approaches to ensuring long-term performance of stormwater control measures. You can always tell who has outreach people work on their titles and who's an engineer. Anyway, just a warning, if you decide to get up during this talk, the middle aisle, you'll walk right into the camera, which I did earlier, so there's going to be like a piece of me with my deer in headlights face in someone's talk. You might want to go around the sides if you need to get up. Please silence your cell phones. So talking about this from CONTECH is Jeremiah Lehman, and he is the Northwest Regional Regulatory Manager for CONTECH. He holds an MS in Environmental Engineering from Tulane University, and I hear he's got a bit of an accent, so focus. And he's spent 15 years in the stormwater industry. He has experience in system design, regulatory development, and lab testing, and he's been fortunate enough to work on projects and programs throughout the US, Italy, New Zealand, and China. Welcome, Jeremiah.
Thank you. There we go. How y'all doing? Just gonna give me grief about my accent. I will try to enunciate as well as possible. So yes, we're looking at how to ensure long-term performance for these stormwater control measures here. When I say stormwater control measure, I'm using this term synonymous with BMP. And just for clarity, we're talking about post-construction here. Most of what I'm going to go through is at the topical level, but there's a lot of information I'm going to cover. There's going to be a number of specific examples of permit and ordinance language at the end. If I brush through them quickly, you don't really want to focus on all those words on the page anyway, but the references will all be there. So if you want to look at the things later, they'll be available. All right. So these stormwater control measures that we design, we approve, and then we install throughout our landscape. We don't do this as a one-shot deal in order to check a box off the permit requirement. We really do expect that these things are going to continue to perform as they were designed throughout the entire life of the project. So that means if they're working, they're going to need maintenance. They're removing pollution from the water that they're treating. If they're going to continue to be able to perform their flow control functions, they will need periodic maintenance. So maintenance in this case can be determined up front in the design stage. So when I look at longevity relative to some of the other design variables that we commonly talk about and use, two that come up often are performance and the hydraulic loading rate. And these three sort of play off of each other in that standard three-legged stool analogy where if you mess with a couple of them and try to increase those, you will be sacrificing on that third. Typically, performance is standardized. That's in your permit requirements or your manual requirements. And then from a developer's perspective, oftentimes the initial capital cost savings of increasing the hydraulic loading rate outweigh the long-term implications of the O&M over the life cycle of the project. And that's particularly true when a developer is going to sell that development on, right? So in this case, we're trying to optimize performance, hydraulic loading rate, so the system's as small as possible, and longevity will therefore be impacted. And I think this is generally accepted, but not necessarily delved into all the time. So it's sort of the elephant in the room on the three-legged stool, if you'll forgive the circus analogy. But so first, I would just want to look at a couple sample installations. And as a design function, as a designer, we look at these things and also as a plan reviewer. And there's some obvious things that can jump out for us in terms of whether or not these systems can be maintained. So here we've got a pretty standard, where are we at there? Here we go. Pretty standard Portland planter box. This is in Northwest Portland. And is it maintainable? Absolutely. You can get to it from the sidewalk. They haven't done much with the plants here in a little while, but you can certainly inspect it. You can certainly access it. And maintenance, as far as this design is concerned, is quite possible and pretty easy. System like this, not so much. You don't have any maintenance access. Once this thing is completely buried and underground, you better have some pre-treatment up front of it. Otherwise, it will silt up. You won't get the storage volume or the infiltration capacity that it was designed for. So these are two pretty obvious examples. Some things are a little more nuanced. This is a sand filter, an Austin sand filter in Texas. It's very large, treats a very large site, and I'd reckon it's designed correctly. But the problem here is the maintenance access. So you can maintain it, but there's no vehicle access, there's no way to get irrigation close to it, some of the other common tasks that would be needed to properly maintain this. So someone will have to get in there by hand, and even given labor rates in Texas, this is likely to be a pretty high O&M burden over the life cycle of this stormwater control measure. We talk about maintainability. There are those aspects that we can control with the design, but a lot of it also comes off the site. It's very site-specific. And this is really what determines how often we have to maintain these things. So this is a storm filter. It's a cartridge-based media filter housed in an underground vault, and this one's brand new. You could eat off of it if you were so inclined. And over time, though, depending on the site pollutant loading rates and the amount of sediment coming into it, you won't really know by the time it turns into this without an ample and frequent inspection program going on. You're going to hear me say inspection a lot of times throughout this presentation. So for lack of inspection, you could end up going to this, although that's pretty ridiculous. To be fair, we do think this was caused by construction sediment that wasn't properly maintained, but it illustrates the point pretty well. Some things, again, are a little more nuanced. Sometimes maintenance frequency should be determined by a different seasonal phenomenon. So this is a system that we had in Olympia that we were testing for water quality, and when we opened it in mid to late spring, it's just like it is outside here, the entire site is just covered with these beautiful, vibrant pink blossoms from, these cherry trees. And so when we opened up the vault, I'm looking in there, everything's bright pink, it was sort of surreal. And I don't know if you guys remember those little Hostess snack cakes, that covered in the snowball things? That's what it looked like. The whole thing was just full of it. So that's not a lot of sediment, that's not a lot of load, right? So we weren't so much worried about the load of this stuff occluding it, but we noticed in the ensuing weeks, what you might expect, there was a lot of export of soluble nutrients from here as the stuff broke down and was carried out. So if downstream I had a nutrient-sensitive receiving body, I'd be pretty careful about maintaining this thing at seasonal events, also in the fall, right, when the leaves are falling. So just some things to think about that are site-dependent. Failure mechanisms with these systems can also be pretty obvious, like this one right here. This is a grass swale next to an undisclosed fast food place. Whether or not somebody decided to dump the fryer grease into here one night, I don't know, but it's obviously not working, right? Pretty clear failure mechanism. Other times, other things could be far more nuanced. So on the left here, you've got kind of the top view of, where's my laser? This is another Portland bioretention cell, and it's receiving water from the sidewalk through these curb cuts. And you look at it, it's also receiving water from the roadway. It looks in great shape. Vegetation's vibrant. I don't see a lot of trash and debris in there. But you'll notice that the only inlet and outlets from the street, where am I at? Up there, are these little trench inlets, right? And they're covered. You get down there and check it out, the thing's completely occluded with leaves. So if I'm an inspector just coming by, taking a look at this thing, I'd say this thing looks great, but it's not receiving any flow. So inspections, all these nuanced things, this is just one of a host of other tasks and different elements of local stormwater programs, which got a nice list over here. It's huge and daunting looking, which is why I chose it. Even though it's from AASHTO, they were good enough to put a list together, so this is meant more for a transportation agency, but there's certainly a lot of overlap in the municipal sector here. And as we know, ratepayers out there are just absolutely cognizant and aware of all of these different functions that they have to do, and they're just willing and eager to give ever-increasing utility rates, right? No, so stormwater program resources are all very limited. So how can we put in programmatic approaches that maximize the resources we do have to ensure that we get the longest longevity out of our systems and we're continuing to meet our water quality and flow control requirements with the systems that we installed? I'm going to look at some of the maintenance requirements just to get an idea of what different agencies and municipalities have to deal with here. This is taken from Alexandria, Virginia, and it's typical bioretention maintenance requirements. There's a lot of simple-looking tasks over here, some less simple than others, but what you'll notice is the frequency is all over the place. Some of these things are recommended to be done biannually, quarterly, as needed, so every 2 years, every 3 years. This becomes hard to schedule around and consumes a lot of man-hours within a program. Even in the manufactured treatment devices that are out there, we have these things developed typically to last a little bit longer, but they do concentrate a lot of pollutants in a small environment. So when we have to come and maintain these things, there's quite a bit to do as well. Depends on what the system was designed for, right? You'll probably need a Vector truck. They're underground. You'll probably need somebody with confined space certification. These type of things are there. But because of the design of these and the site-specific requirements, it's hard to get a feel on this without a lot of inspection. Costs are another barrier to implementing all of this stuff. This comes from a great publication by Jane Clary and Holly Pisa that was rolled out, I should say, at the 2017 EWI O&M conference in Denver, if any of y'all were lucky enough to be there. But you'll notice these cost information are all over the place, right? These data are highly varied. But they do come from a nice, diverse group of sources. And if we just play with the averages here and assume a little higher than the median, if we just say $1 per square foot per annum for bioretention maintenance requirements, and you consider your typical designs like 4 to 5% of impervious acre on a given site, it's 2,000 square feet per acre at $1 per square foot. That's $2,000 per acre per year. Costs are also available for the manufactured treatment systems. As I said, these are meant to last often a little bit longer than the non-proprietary systems, but you do have this concentration of sediment and pollution there. That requires disposal costs, that requires a lot of concentrated effort and machinery. So we see typical costs at about the $1,500 per event range here. So somewhat comparable. And let's not even get into private sites, right? This has a whole host of other problems for it, for the public sector. Can you access the site? Do you have enforceable regulations and ordinances that will allow you to force compliance with maintenance requirements? What happens if a property changes hand, like we said, from one to another? How are we keeping track of that? So, an integrated regulatory framework is definitely key to managing and keeping all of this together. And this starts at the top with the permit language and goes down to the municipality within specific ordinances that empower those local programs to enforce the requirements that are set in the permit. These things need to be dovetailed together and integrated. And I'm going to go into a lot of examples right here of language for that. It's going to be pretty quick, but please do remember that the references are all provided. So for permit language, a really good source, even though it's approaching 9 years old, is this 2010 EPA document where they released a NPDES permit improvement guide. And there's a lot of language in there that specifically addresses these things. The long-term maintenance requirements, inventory and tracking so you know where these systems are, and inspection and enforcement. I'll give you the link to that in just a second here. And then model ordinances are available. There's a lot of references out there, so you're not reinventing the wheel. I've got just a couple examples here. One's from the state of Illinois, and they give you specific ordinance detail about having right-of-way passage into facilities, being able to construct operator and permittee maintenance agreements and stuff like that. The city of Carlsbad also has a very good documented enforcement mechanism that we'll touch on in a couple minutes. So back to the EPA language. Don't bother trying to read all of that, but the bold words that we put in there really do address some of these major elements. So the EPA has written this for you. You know, you're going to develop and implement a maintenance agreement. It allows the permittee or his designee to conduct inspections on the site. to go in and actually conduct the maintenance for the owner-operator and recoup their costs if necessary. So these are important program elements that are out there. An example of one of these maintenance contracts is pulled out of the Boise, the appendix of the Boise, City of Boise Stormwater Manual. Here. This specifically lays out who's the owner, who's the permittee, what is the location of this stormwater control measure, what are its maintenance requirements, all the relevant information that's in there. Grant the permittee access to it. And all this stuff is done up front before the final approval is granted for these projects. If I were a maintenance operator, I'd be going to developers who have potential sites out there and saying, hey, I'll go ahead and give you a maintenance contract. You can put that in with your report and reference us in your maintenance contract and ease that on through. So having this stuff identified up front and having contractual obligations is a very good way in an enforceable manner for a local municipal permittee to take huge steps ensuring that private sites are maintained. Or you could just take it out of their hands completely. This is the City of Gresham's website for their storm drain cleaning assistance program. And for a flat fee of $45 per storm drain, they'll come and clean it out for you. Additionally, they require that most underground systems be placed in the public right-of-way so there's no conflict or no access restriction for them. So it's pretty forward-thinking. It's paid for by the site owners and the developers, and it allows them to maximize their scale of economy and also ensure that they've got consistency across their program. Fundamental to all of this is being able to track and locate where these systems are. So having an inventory and a database where these things are itemized and identified is critical. If you can tie that in with your GIS systems, it makes it even more useful, especially for future sort of additional requirements like capital improvements planning or, well, it just also makes it very accessible because people understand maps, so you've got it all in one place. And that, with GIS, you have the ability to put in all sorts of other attributes. And so this is something that the LA Regional Water Quality Control Board has capitalized on. And they identify specifically what needs to be in their stormwater control system database. So this content is in there so you know what the system is, what its type is, the date it was approved, last time it was maintained. LA requires maintenance records that go back for 3 years, so you've got a pretty good history on this. So again, just some smart approaches from what other people have done. We talk about inspections. The fundamental, most important inspection is probably as-built verification. Now, I love this photo. This is not in the US, but I'm sure this has happened here somewhere as well. And it's a clear case of designer meet contractor, right? So even if you do have your as-builts out and the system was installed where it's supposed to be, there's a lot of other design variables and attributes that can't be checked or proven just with a visual observation, right? So can we ensure that, for instance, a bioretention system wasn't compacted by equipment during installation? So here's just a couple of examples. This is from some language from Delaware's what is that? Their Natural Resource and Environmental Control Agency. They've got a post-construction verification worksheet where they require infiltration testing after installation. And they require documentation of vegetation health and ensuring that elevations are correct and pretty specific stuff. Yeah, you might have to get a survey crew and somebody to do an infiltration test, but they could potentially hold back your occupation certification if you don't have this done. Besides the as-built and immediately afterwards, routine ongoing inspection is very important, and I would say it's even more critical within the first couple years of an installation. This gets back to those site-specific variables that really control system longevity in conjunction with its design. So a lot of agencies will go off of inspection, predictive inspection intervals, and I would argue that, for any given system out there, there's probably a lot of documentation saying about how long it'll work. But within a given site, there's a lot of variability. So that inspection, especially in the first couple of years, should be at least half of what that predicted maintenance interval is going to be, just to ensure that everything's looking right relative to that specific site. Another smart thing that we've got here in Washington is spot inspections in the Phase 1 permit after large events. Well, that makes sense. You just had your 10-year, 24-hour rain event, which seems to happen every week. But when this happens, go out and take a spot check at some of these systems. Ensure that there's not damage, all right? And finally, we get to the progressive enforcement element, and this is really what comes out of this City of Carlsbad ordinance that I referenced earlier. And this is very well thought through. So they do require that the site owner contribute annual inspection and maintenance reports. If you don't do that, they'll remind you. If you still don't do it, they'll come do it for you, and then they'll send you the results and a bill. And if you still don't follow up then, they'll come on your site, they have the right to do so, they will conduct the maintenance, and they'll charge you for it. And it's nice to know that at any point along here, the owner-operator can keep the next escalation from happening by complying. But there is an enforceable outcome that brings these systems back into maintenance. So building these city ordinances, again, that are in line with permit language and really offer you this integrated framework is critical. So I offer you to go back and review some of these references that were here. There are so many references available out there, so it shouldn't be too hard to cobble together a good program. But those routine inspections and those as-builts are probably the major thing that'll go the distance for you in terms of having positive outcomes for longevity. So that was pretty quick, but I think I saved some time for questions. Yes?